Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, similarity, we are getting into 15a, the three sums that we had left in the previous video, 26, 28 and 5, and then we'll get on to exercise B. So what is there in exercise B, I'm going to talk a little later, we'll come back to this page. As of now, only two things you have to remember, the three tests of similarity, SSS, AA, SAS. CSST and CAST. These only two things if you remember. We'll be able to do sum number 5, 26 and 28. We come back to this page later on and we'll understand what is there for exercise B. So here you go with sum number 5. So for sum number 5, they say that ABC is double of ACB. So this is double, I consider this as x, so this will be 2x. And then this is the bisector, so each will be x. So let us just write that much and then we'll come back to see what we have to do. So firstly they said, we are saying let ACB be x. Therefore ABC will be double x. And since ABC is double x, therefore angle ABP will be equal to PBC will be equal to x. So we managed to prove all of them as x. Now that everything is x, we clearly know that this is an isosceles triangle. So I can say PB equals to PC. So immediately, therefore, triangle PBC is an isosceles triangle. And now that it is an isosceles triangle, I can say therefore PB is equal to PC. This is what we are going to use later on extensively. Now, let's understand what we have to prove and how are we going to prove that. So you got to prove that CB ratio BA equals to CP ratio PA. It's going to be slightly logical. So we'll take a fresh page first. We'll try and understand the rough statics of this and then we'll go ahead with understanding of this. Okay. So I'm just taking a rough sheet. Alright, now let's say you take two triangles. One is APB and the big triangle ABC. So let's say if we've taken these two triangles and we try to prove them similar. If you do that, then what will happen? Why these two triangles? So first let's analyze this. CB upon BA is equal to CP upon PA. This is what is you have to prove. CB is here, BA, CP, CP is here and PA. CP can also be written as BP, remember that, okay? So BP can be a big clue for us. So basically what we are going to do is we'll take these two triangles, prove both the triangles similar. Once you prove them similar, how will you write one-to-one correspondence? ABP similar to. Now ABP, so for the big triangle, A is the common angle, so in the place of A, one-to-one correspondence. For B, which is X, so in big triangle, what is X is C. And for P, which is the third angle, so for big triangle, the third angle is B. So here you got one-to-one correspondence. Now look at this carefully. I am taking AB or BP rather upon BC equals to AP first and last upon AB. Now this I am trying to compare with what is needed. So what is needed is CBBA, CBBA, alright. So first let's do the reciprocal of this. So CB upon BP, AB upon AP, right. Now we can do this alternando. So CB upon AB, BP upon AP. So at least my LHS is sorted. For RHS, AP is sorted. BP, in that place I can write CP. In the place of BP I can write CP because both are equal, and then you will get that. Yeah. So basically we need to take these two triangles, that is ABP and ACB, prove them similar. Once they are similar, CSST, invertendo, alternando. Alter means you're sending this up and this down, changing the positions, and then changing BP to CP to get here. Yeah. So you will have to be with me for some time. Going ahead can be dangerous. Try if you can. Otherwise, I am there to help you. So I will start with the triangle APB and triangle. Now APB So APB. So for A I'm going to write A. For B I'm going to write B. For P I'm going to write B. And for B, that is X, I'll have to write C. So this is going to be ABC. Are you getting it? Now how are you going to write it? So step 1 I will say angle ABP, first, last, second. So first, last, second equals to ACB. ACB, each X. So we are sorted with this. Then I will say angle BAP. BAP. So last, first and next. So last, first and next CAB. Common angle. You can notice BAP is this angle and CAB also is the same angle. And therefore I can say triangle APB is similar to triangle ABC by AA test. Once your triangles are similar, therefore, now you got to be very careful. Do I need to take AP? Yes, I need. So let's take AP and write it as PA upon BA, because you need BA, is equal to, should I take PB? Yes. So PB, second and last, upon BC or CB, CSST. Now let's try to match it with this. This should be first, CB. So you'll have to reverse this. So that will be BA upon PA, CB upon PB. Are you getting it? Then AB should come below CB. CB, AB. So you're going to do the alternando here. So step 7, therefore, pushing PB up upon PA is equal to, see, PB has gone up upon PA, CB upon BA. This we call it as alternando. Alternando. Finally, PB, I don't need it. So for PB, I am writing it as CP upon PA equals to CB upon BA. Reason you can write from 1. Write this as small 1 with a dot. So from 1. We could change CP as PB. So finally step 9, therefore CB ratio BA is equal to CP ratio PA. There you go with that one. Are you getting it? I understand that I have messed this up slightly over here for lack of place, but yeah, you'll have to work it out. So first thing is to pick this small triangle and big triangle, prove them similar, CSST. And then your eye should be on the RHS always and LHS both, what you have to prove basically, and then you can start working on this. Now second part, BABC. So look at this now. Taking the same two triangles, if I take BA, that is first last AC, and then BC BP. So BP BC. Automatically you'll get, don't worry, just start as it is, AB first and last upon AC first and last, BP second and third, BC second and third, again CSST. Let's cross multiply AB into BC. So I got at least one part. PB into AC, I got the second part, or BP into CA, one and the same. So we got our second part also, that was expected from the same two triangles. So these two triangles were very important for us in order to bring out the two parts. So we got both the parts. I hope you managed to get this sum. Yeah. Let's go with the next one. Sum number 28. 28 is not that difficult. In fact, we should go for 26 first. Then we'll go on to 28. So 26, the diagram looks like this. They say that PQ ratio AC is what you have to find. You've been given AP ratio PB as 4:3. Your target is to find PQ ratio AC. So for PQ, obviously you're going to pick up this triangle here, because you know this has 3 parts and PQ you need. And for AC, you can pick up the big triangle ABC. So I'm pulling out both the triangles here for our reference, one big and one small. I call this as CAB and this one as QPB. Alright, we've been given that APPB is 4:3. If we prove these two triangles similar, then BP upon BA, whose values are known to us to some extent, is equal to PQ upon AC, and we will be able to get this. But before that, we'll have to find PB upon AB. Right now we have AP. So we introduce a new method called as X method. What is this X method? So you first write AP upon PB as 4 upon 3. And then you say let AP be 4x. So PB will be 3x. Therefore AB, see this is 4x, 3x, so entire AB becomes 7x. And therefore PB upon AB, that is what we need. So PB is 3x and AB is 7x, 3 by 7. So we managed to get PB upon AB. This is called X method. We are calling it as X method, so that always we can understand that when parts are given like this and you want full PB upon AB, you can use the X method. Very important, don't forget that, okay? Now that you know PB upon AB, jump into these two triangles, lines are parallel. So you can use corresponding angles and prove the two triangles similar. So let's do it. So in triangle QPB and triangle CAB, this one and this one. First one I will say angle QPB equals angle CAB. Then angle PQB equals ACB. Both are corresponding angles, and therefore triangle QPB similar to CAB by AA test. Once your triangles are similar, now you can say PB upon AB, second, third equals to PQ upon AC, CSST. PB upon AB already 3 by 7, so PQ by AC also now I can write straight away. So I'll say therefore PQ upon AC also is 3 by 7. From, oh I forgot to write statement numbers, so let us write the statement numbers right from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So on 10th one I can say from 4 and 9. These two statements help us to get this, and finally I want to write it in the ratio form. See, they have asked in the ratio form. You are supposed to write it in the ratio form, otherwise you will lose your marks. And therefore PQ ratio AC 3:7. That becomes your first part. Now for the second part, they say QS is 6. Find AR. So which triangles are we supposed to look at? So one is this small triangle for QS. Because you know PQ, you are finding QS also known. And this is the other triangle that you can look out for. Because you know AC and AR you are trying to find. See, picking the triangles is very, very important. Without that it is nearly impossible. So 1 and 2, we will prove the two triangles similar. One is each 90. And second, can you see the Z going over here? Alternate angles. Therefore the triangles will be similar by AA test. Once the triangles are similar, I will say PQ upon AC, which is known, QS upon AR, and I will get the value of AR. So come on, let's write. First write 4 steps, come back, then we'll go ahead. So 4 steps for in triangle PQS and triangle, correct 1-to-1 correspondence, PQS, so starting from P, that is dot, and then going to this and then 90, so CAR, car. I will say angle PSQ, so PSQ CRA, each 90, correct. Then I will say angle SPQ, so SPQ RCA, alternate angles, and therefore I can say triangle PQS similar to triangle CAR by AA test. Once the triangles are similar, therefore PQ upon AC equals to QS upon AR, CSST. So substitute the values. PQ by AC 3/7, QS is 6 upon AR, 3 ones are 2s are, and finally I can say AR is equal to 14 centimeter. Wow, so we managed to get the second part. I was worried whether will I be able to fit it in this page. We managed. So that's your question. First we picked up the two basic triangles PQB and ACB, these two. Prove them similar. Before that we used X method because they gave us APPB. So in this one sum they have asked us everything. They asked the two tests, that is AA test, then they asked CSST, they asked X method, everything we did and we got the sum finally. Let's go to the next one. I want you to try sum number 28. So come on, go for it. 28. That's your diagram. A good question and not that simple either. So let us try how to go about it. Sum number 28. They say that CE and BD are medians. So median, that means they hit at the midpoint over here. So these parts are all equal. Prove that EGD over here, the triangle in the center, is similar to CGB, here the triangle at the bottom. Now they have not told us that the lines are parallel. So I can't use alternate. What I can use is only vertically opposite and nothing else. There is a property of median which says that median by this midpoint, that is centroid, bisects the median in the ratio 2:1. This is basically the derivation of that. So don't use that directly. We are trying to prove that only. Okay. So now how are we going to go about it? So I will start by saying AE upon EB is equal to 1 because AE is equal to AB. Then I can say AD upon DC is also equal to 1. So therefore AE upon EB equals AD upon DC. Are you getting this? Yeah. So with this you got AE upon EB equals AD upon DC. So there is a property called as BPT and converse of BPT, which we are going to do in the next exercise. I am trying to use that right now only. Okay, let's not use that. We'll do it in the next exercise only. Don't worry. So we'll go by the traditional method. So we'll try and prove that AE upon AB equals AD upon DC. How? So you'll have to be a little careful here. Otherwise, it's going to be tough. EB upon AE, DC upon AD. This is called invertendo. We just inverted. Reciprocal. Okay. Why did I do that? So EB plus AE upon AE, DC plus AD upon AD. This is called componendo. Do you remember ratio proportion? Superb. Now see, some magic will happen. EB and AE. EB plus AE is AB upon AE. Likewise DC plus AD is AC upon AD. Why did I do this? So now I can take these two triangles AED and ABC, prove them similar by 2S and the common angle SAS test. So see how will we write. So my step 7 should be in triangle AED and triangle ABC. Come on, go ahead. First I will say AB. Okay, I should have written the bigger triangle first, ABC, and then AED. Okay, so AB upon AE equals AC upon AD. From 6 we got this. Ninth one, angle EAD. Oh, again I should have written BAC, sorry. So angle BAC equals EAD, common angle, and therefore I can say that triangle ABC is similar to AED by SAS test, because we got the two sides and one angle in the center equal. So you got SAS test, the two triangles similar. But why did I prove them similar? So that I can now say angle AED is equal to ABC. Reason CAST. But why do I want this angle equals to this angle? So that I can say ED is parallel to BC, corresponding angles test. Once I got these two sides parallel, now I can pick up these two triangles, prove them similar by AA test. But before we move ahead, let's look at the second part, BG double or GD. For that we'll prepare something. We'll say AE upon AB equals to ED upon BC. CSST, because these two triangles are equal. AE, and for AB I am writing double AE because E is the midpoint. ED upon BC. Why did I do this? So that ED upon BC will become 1 by 2. This is going to help me to get this one later on. So I'm thinking from the point of view of what you're going to do next, right? So let's take a fresh sheet and continue with the same sum ahead. Now we get into these two triangles finally. So after 14 steps preparing everything, you can now jump into the triangle. So what did we do first? Recap till here. First we tried to prove that AE upon AB equals to AD upon AC, which came here after 6 steps. Got them equal, componendo, and then we got this. Once we got these two equal, then we proved these two triangles similar by SAS test. Then we said these two angles equal, therefore lines parallel. Once we got lines parallel, after that we said that AE upon AB, ED upon BC, so that it becomes half. And now we are getting into these two triangles finally. So step number 15. So let's write it. 1, 5 in triangle EGD and triangle CGB. I will say angle EDG equals to CBG. Angle DEG equals GCB. Both will be called as alternate angles, and therefore you can also use vertically opposite, no problem, whatever you wish. Similar to CGB by AA test. So finally we managed to prove these two similar. And now the most important thing for this second part, okay, I will say GD upon BG, ED upon BC. Basically from here, see, first second, first last. This is CSST. So now that I got this, I already know ED upon BC is half. That's why we did that. So now GD upon BG is half from 14 and 19. Finally, I can now say therefore, cross multiplying this, BG double of GB. That's what your second part is. So it's a lengthy sum. Yeah, it's a good question. We will have to practice it really well. So let's go through the question once again. So starting from here, first we said AE, EB, AD, DC both equal. Why? Because both these are midpoints. Once they got equal, then we used componendo to get AE upon AB, AD upon AC, so that I can prove triangle AED and ABC similar by SAS test. Once you got them similar, we said these angles equal, so lines are parallel by corresponding angles test. So we got the lines parallel. Why we wanted lines parallel? So that I can prove these two triangles similar by AA test. Also, I knew the second part was this. For that I prepared AE upon AB as 1 by 2, which is equal to ED by BC by CSST. And then finally we jumped into these two triangles, proved them similar. That's the first part. For the second part, used CSST, substituted this as half from here, and finally I managed to get BG double of GD. Lot of work. Similarity, good chapter. Don't worry, gradually it will become simple for you. I am there. I will not leave you. I will hold you right till the end. Okay, so that's with exercise 15A. I think we can pause over here. For 15B, we will do this B maybe in the next video, because this only took a lot of time. So let us go in smaller chunks so we absorb very well. So I'm just doing 3 sums in this video, because all these 3 sums are very, very important and you should get a good hand on it, right? So please see to it you do it very well. Alright.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.